Good day everyone. We are the Group 1 and we're going to present the introduction to data structures and algorithms. So what is data structures? Data structures is representation and the operation allowed on that data. It is a way to store and organize data in order to facilitate the access and modification. It is also the method of representing of logical relationships between individual data elements related to the solution of a given problem. So we have the basic data structures. Let's first list the most commonly used data structures and then we'll cover them one by one. So as we can see, there are two types of data structures, the linear data structures and non-linear data structures. Under linear, we have arrays, linked lists, stacks, and queues. While under non-linear, we have trees, graphs, tables, and sets. Type of data structures, linear. A linear data structure is one in which data items are ordered sequentially or linearly, with each member attached to its previous and next element. Since the data elements are stored in a linear fashion, the structures allow single-level data storage. We have array, linked list, stack, and queue. So an array is a fixed-size structure that store multiple items of the same kind of data sequentially. In array index, each item starts with 0. In linked list, the items are arranged linear order and connected to each other. It consists of nodes where each node contains a data field and a reference or link to the next node in the list. For stack, it is a structure known as LIFO, which means last in, first out. The element placed last can be accessed first. Stack are commonly used for parsing and evaluating mathematical expression and to implement function. For the last one, we have queue. If the stack is LIFO, the queue is FIFO, which means first in, first out. We can enqueue an element in these structures, which means inserting the element to the end of the queue. We can also dequeue to delete an element from the beginning of the queue. After the linear data structures, we have nonlinear. Nonlinear is a form of data structures where the data elements don't stay arranged linearly or sequentially. Since data structure is nonlinear, it does not involve a single level. Therefore, a user can traverse all of its elements in a single run. We have tree, graph, hash table, and set. A tree is a data structure consisting of vertices or nodes and edges that connect them. Trees are similar to graphs, but the key point that differentiates a tree from the graph is that a cycle cannot exist in a tree. A graph is a set of nodes that are connected to each other in their form of a network. A pair of x and y is called an edge, which indicates that vertex x is connected to vertex y. In hash table, it is a process used to uniquely identify objects and store each object at some pre-calculated unique index, called its key. They are mostly used to create associate arrays, database, index, and set. So the last one is set. A set is a collection that contains no duplicate elements and whose elements are known in particular order. The capacity of a set object is the number of elements that the object can hold.
Next is in abstract data type. Abstract data type, or ADTs, stores data and allows various operations on the data to access and change it. It is a mathematical model together with various operations defined on the model. An ADT is a collection of data and associated operations for manipulating that data. ADT supports abstraction, encapsulation, and information hiding. Abstraction is the structuring of a problem into well-defined entities by defining their data and operations. It is the principle of hiding the use of data structure, and to only provide a well-defined interface is known as encapsulation. Then the core operations of ADT. In every collection of ADT should provide a way to add an item, remove an item, find, retrieve, or access an item. Many more possibilities. Is the collection empty? They make collection empty. Give me a subset of the collection. What are algorithms? An instance of logic written software by software developers to be effective for the intended target computers, for the target machines to produce output from given input, perhaps null. It is a mathematical method of solving problems, both big and small. It is a set of instructions for solving problems step by step. It is an effective method expressed as a finite list of well-defined instructions for calculating a function.
Expressing algorithms is an instance of logic written in software by software developers to be effective for the intended target computers, for the target machines to produce output from given input, perhaps null. Algorithms can be expressed in many kinds of notation, like natural language, pseudocode, flowchart, and programming language. Natural language is verbose and ambiguous and are rarely used for complex or technical algorithm. Pseudocode is an English-like syntax that resembles a programming language. Flowchart is defined as a diagrammatic representation of an algorithm, a step-by-step approach to solving a task. Programming language expressing algorithm in a form that can be executed by a computer. Examples of algorithms are find the places you can go from home. From each of those places, find all paths. Keep track of the distance you have traveled as you go. Repeat this process until you get to school. Compare the distance you have traveled. Find the shortest path. Criteria of algorithms. Input, which are 0 or more input. Output, which must produce output. Finiteness must have ending, while definiteness is unambiguous and clear. Correctness should produce the correct output. Efficiency means in less time the result is obtained. Effectiveness means that every instruction should be clear, it should not be complex. Generality is where the algorithm should be applicable to all problems of a similar form.
Problem-solving concepts. The first one is problem definition. Next is algorithm design or algorithm specification. The third one is algorithm analysis, then implementation, followed by testing, and lastly, maintenance. Problem definition. These are the questions that helps you to define the problem. What is the task to be accomplished? What are the time, space, speed, or performance requirements and resource needed? Algorithm design or algorithm specification. It describes in natural language, pseudocode, or diagrams. It follows the criteria. Input, 0 or more quantities. Output, 1 or more quantities. Definiteness, clarity, precision of each instruction. Finiteness, the algorithm has to stop after a finite, maybe very large or number of steps. Effectiveness, each instruction has to be basic enough to feasible. Algorithm analysis, important part of computational complexity theory, which provides theoretical estimation for the required resources of an algorithm to solve a specific computational problem. Space complexity, it is how much space is required. Time complexity, it is how much time does it take to run the algorithm. Implementation, implementation is a realization of a technical specification or algorithm as a program, software component, or other computer system through computer programming and deployment. It decides on the programming language to use. Write clean, well-documented code. Testing. Testing is used to find out how well something works. Key checkpoints in the overall process to determine whether objectives are being met. Use different types of testing appropriate to the output. Conduct series of testing. Integrate feedback from users. Fix bugs. Ensure compatibility across different versions. Maintenance. Integrate feedback from users. Fix bugs. Ensure compatibility across different versions. An algorithm is a finite set of precise instructions for performing a computation or for solving a problem. A program is one type of algorithm. Directions to somebody's house is an algorithm. A recipe for cooking a cake is an algorithm. The steps to compute the cosine of 90 degrees is an algorithm.